Alright, so let's look at the solution I've come up with for this Russian peasant algorithm. Well, all I've done is I've defined a function called Russian, and I've passed it two inputs. These are going to represent our two numbers. And I've just given those arguments names A and B. Then I'm going to go and assign some variables. So I have X here, I'm going to assign that the value of A. And I have a semicolon, and then I have Y, and assign that the value of B. So this might be something you haven't seen before. I'm using this semicolon to create a compound statement, just to condense the code a little bit. It's a neat little trick you can do with Python. Then I'm going to have a variable called Z, and I'm going to assign that the value of 0. Now, Z is going to be an accumulator, so that's just going to add up the numbers every time we want to add a number to our running total here. We're going to use Z to do that, and that's going to be our final outcome for what A multiplied by B will equal Z. Next thing I'm going to do is start into a while loop. Now the while loop is going to be controlled by X being greater than 0. If X is equal to or less than 0, then the while loop no longer runs, and we will return Z down here at the bottom. But inside the loop is where all the magic happens, and we're going to begin with an if statement saying if the remainder of X divided by 2 is equal to 1, we're going to run this bit of code here saying that Z is going to equal Z plus Y. Now there's another way you can write this. We can say plus equal Y, but just as an easy way so everyone can read the code, we'll just say Z plus Y. So what is this percent sign here? Well, that's called a modulo operator. And what that does is it takes the two numbers and divides them, and then it equates to the remainder of those two numbers being divided. So if we had an even number as x, so say 10, and we divide that by 2, the remainder would be 0. And if we had an odd number, say 5, and we divide by 2, the remainder would be not 0. So we're going to have x having the modulo operator of by 2 equaling to 1 will represent an odd number. And remember from our previous video, if we have an odd number, we want to add those numbers together that were in that row, meaning the y. So every time we run into an odd number at x, we're going to add that y value into z, our accumulator. So that's sort of what's keeping our running total. After we're done that, what we need to do is, remember, we have to multiply by 2 and then divide by 2. So here, y we're going to multiply by 2 here, and x we're going to divide by 2 here. But wait a minute, what are these little arrow signals for? So these symbols represent some shift binary, meaning we're going to take the binary value of y and then shift the values over to the left by 1. And that's going to accomplish a multiplication of 2. And I'm going to show you that in a little bit. And then we're going to do the same thing for x, only we're going to shift the bits over to the right by 1, and that's going to be the equivalent of dividing by 2. And again, I'll show you how that works in a little bit. But anyways, that was our loop, and then we're going to return z. So let's just run this and make sure it works. 24 by 16, and then I'm going to reverse the number 16 by 24 just to show you that it doesn't matter what order the numbers go in. So let's run that. Then I'll print out 384, which is the answer. Then I'll also just change this number to do a very big number like this, and we'll run that, and we'll come up with our answer pretty quickly of 5,712 for the multiplication of 357 times 16. So pretty neat little function. Now let's explain how this works right here, the shifting of the binary numbers. So if I just come up here, I have some comments that explains this a little bit. So what I'm going to do is use this example of the number 17 to explain how this all works. So the way me and you read numbers and talk about numbers is in base 10, meaning that each position here, where the 7 is and then where the 1 is, consists of numbers between 0 and 9. Once we go outside of that, then we have to move over to the next position here. So base 2 works pretty much the same way, only they only have 2 numbers to work with instead of 10. And in base 2 we have the two numbers are 0 and 1. So once we reach a value over 1, then we have to move over to the next position here, and that would be either 0 or 1, and if we were greater than that, then we'd have to move over to the next position, and so on and so forth. So each position has sort of a value associated with it, the first being 1, the second being 2, the third is 4, the next one's 8, and the one after that is 16, and it'll continue to double as it moves along here. So if we look at this number, we have a 1 in the 1 position, then nothing in the 2, 4, or 8, and then 1 in the 16. So we're going to have 16 plus 1 is 17. That's the number we're looking at. So let's look at this operator here where we're shifting all the bits over by 1 to the right. If we took all those and shifted them over to the right, what would happen is that 1 would fall off the table, and we would be left with 1, 0, 0, 0. This position is 1, 2, 4, 8. That number is 8. And 17 divided by 2, because we're base 2, we're taking that off the table there, we're left with 8. And the actual number is 8.5, but if we're dealing with integers, just like in our last video, we sort of dropped that off the back end and just left it rounding it down to 8. That's what this binary conversion is going to do for you. Let's look at the other example here. We're still at 17, 1, 0, 0, 0, 1. And then we're going to shift all the bits over to the left by 1. So we're going to have 1, 0, 0, 0, 1. And we're going to add a 0 onto the end here because we moved it all over to the left. And if we look at that, we have 0 at the 1 position, then we have 2, nothing at 4, 8, or 16, and then we have a 32. So a 32 plus a 2 is 34. So I hope that all makes sense to you, and I hope this algorithm makes sense, and I hope you enjoyed working on it. Such a simple little thing like multiplying two numbers together can really yield you some really neat programming and a really neat algorithm to get it done. So that's the very first thing we're going to do, and obviously they're going to get much more complicated as we move forward, dealing with actual puzzles and actual games and actual things like that. We're not going to stick with these multiplication questions for much longer, but I did want to show you some new little features, the shift binary stuff, and this semicolon for the compound statement, and also this modulo operator, which you might not have seen before. So we have learned some new things here, and we also did a pretty neat little, really old-fashioned algorithm.